I am Dr. R. Delhi Babu, Assistant Professor, Department of Mathematics, Satyabama Institute of Science and Technology, deemed to be University. So today we will see Laplace transform. Now the definition of Laplace transform is a function f of t which is defined for all positive values of t, and let s be a real constant value if the integral 0 to infinity e power minus st f of t dt exists and that value is equal to f of s, then f of s is called the Laplace transform of f of t and it is denoted by L of f of t. That is, L of f of t is equal to this integral part, integral 0 to infinity e power minus st f of t dt, which is your f of s. Now, this is the definition of Laplace transform. In continuation, that periodic function in Laplace transform. Suppose a function f of t is a periodic function. What is periodic function, sir? If f of t plus a is same as f of t, then f of t is called periodic function. Now, the Laplace transform of a periodic function is nothing but L of f of t, which is equal to 1 by 1 minus e power minus as integral 0 to a e power minus st f of t dt. Now, the next one, definition of convolution of two functions. See, if f of t and g of t are two functions, then the convolution of these two functions f of t and g of t is defined as f of t star g of t, which is integral 0 to t f of u g of t minus u into du. This f of t star g of t is called your convolution function of f of t and g of t, which is equal to integral 0 to t f of u g of t minus u into du. Now, the next convolution theorem in Laplace transform. See, if f of t and g of t are two functions defined in the interval positive interval, then the Laplace transform of f of t convolution g of t is equal to this L of f of t into L of g of t. That means L of f of t convolution g of t is equal to f of s into g of s. That is given here, where f of s is nothing but Laplace transform of the function f of t and g of s is nothing but Laplace transform of the function g of t. So, these are the definition of convolution of two functions and convolution theorem in Laplace transform. Now, we will see the problems based on this. First problem, in periodic function, find the Laplace transform of the function f of t, which is defined as t in the interval 0 to a, 2a minus t in the interval a to 2a, and f of t plus 2a is f of t for all t. Here the period is 2a. Here the period is 2a. Now, already you know Laplace transform of periodic function. L of f of t is equal to 1 by 1 minus e power minus your period. Your period for this problem is 2a into s integral 0 to your period. That means integral 0 to 2a e power minus st into f of t dt. Now, the 0 to 2a as defined as 0 to a and a to 2a. So, two parts they split it. Hence, this integral I will write it as integral 0 to a plus integral a to 2a. Now, 1 by 1 minus e power minus 2a is integral 0 to a e power minus st. In this interval 0 to a, your f of t defined as t. Hence, instead of f of t, I will write it as t into dt plus in second part integral a to 2a e power minus st. Your f of t in the interval a to 2a defined as 2a minus t into dt. Now, it is not possible to integrate directly because two functions are under product. Hence, apply Bernoulli formula. Already you know Bernoulli formula, integral u dv, which is equal to uv minus u dash v1 plus u double dash v2 minus etc. So, apply this. Your u is t and dv is e power minus st dt. Apply this u, that means t, into v. So, integral this e power minus st, its integration is e power minus st by this minus st differentiate will write in denominator, that is minus s. So, uv minus u dash, that means differentiation of this t. Differentiation of this t is 1 into e power minus st, again integrate because u dash v1 is formula. So, e power minus st, its integration is e power minus st by one more minus s come. Already I have minus s. So minus s into minus s as s square. So uv minus u dash v1 plus u double dash v2, that is your Bernoulli formula. U double dash means differentiate this 1 again. What's the differentiation of 1? It will be 0. So hence that's all your uv minus u dash v1 term only exists. From u double dash onwards it will be 0. So in this case interval as 0 to a plus the second part once again apply Bernoulli formula. U dv where u is 2a minus t, dv is e power minus st dt. Apply this formula is uv, so u is 2a minus t into v, this e power minus st, its integration is e power minus st by minus s, uv is over minus u dash, that means differentiation of this 2a minus t. 2a is constant, its differentiation is 0, minus t differentiation is minus 1 into v1. So integrate again this e power minus st. What is integration of e power minus st with respect to t? E power minus st by 1 more minus s will come again. So already I have minus s in denominator. Hence minus s into minus s as s square. uv minus u dash v1 plus u double dash v2. Differentiation of this minus 1. Again minus 1 nature is constant. So minus 1 differentiation will be 0. Hence that's all, your limit is a to 2a. Now apply your upper limit instead of t equal to a as first. So before that I will write this minus sign in numerator. So I will write this minus sign here, minus t into e power minus st by s minus, when I multiply this term by 1, we will get the same term e power minus st by s square between the limit 0 to a. Now 2a minus t into e power minus st by minus s is there. If any minus in denominator, then you can write in numerator. Hence this minus sign comes to the numerator, 2a minus t e power minus st by s, minus into minus it will be plus. When I multiply by 1, we will get same term e power minus st by s square between the limit a to 2a. Now I will apply the limits in the next slide, that is 1 by 1 minus e power minus 2as into, I will apply upper limit first, t equal to a, we will get minus a e power minus as by s minus e power minus as by s square, that is your upper limit. When I substitute t equal to 0, it will become 0 for the first term. Hence I have only second term minus 1 by s square. This minus sign as a lower limit, before that we will put minus sign, plus again apply upper limit t equal to 2as first, we will get e power minus 2as by s square. Before going to lower limit, put minus sign. Substitute t equal to a, we will get minus a e power minus as by s plus e power minus as by s square. Now multiply this minus sign with bracket terms, minus a e power minus as by s minus e power minus as by s square, minus into minus becomes plus 1 by s square plus e power minus 2as by s square. Now apply this minus sign with bracket term, minus into minus becomes plus a e power minus as by s minus into plus minus e power minus as by s square. Now see the first term and fifth term, minus a e power minus as by s plus a e power minus as by s gets cancelled. So minus sign plus sign gets cancelled. Now I will write the positive term as first, 1 plus e power minus 2as. See the second term and last term both are same, that's why minus e power minus as by s square minus e power minus as by s square as minus 2 times e power minus as the whole divided by s square, which is, now this is of the form a square plus b square minus 2ab, that means a minus b whole square. By the denominator, this 1 minus e power minus 2as, for my convenience I will write it as 1 square as 1 minus e power minus as whole square. You know a square minus b square, which is a minus b into a plus b, that is 1 minus e power minus as into 1 plus e power minus as. So 1 by s square whole square, one term gets cancelled, and then take e power minus sa by 2 as common in both numerator and denominator, both are gets cancelled, and further this term becomes tan h as by 2. So hence your Laplace transform of the function f of t, which is f of s, is 1 by s square tan h as by 2. Now we will see convolution theorem problems. Now find the inverse Laplace transform of s by s square plus a square into s square plus b square by using convolution theorem. Already you know convolution theorem in Laplace transform says L inverse of f of s into g of s is nothing but L inverse of f of s convolution L inverse of g of s. So L inverse of s by s square plus a square into s square plus b square as L inverse of, I will write s by s square plus a square into 1 by s square plus b square. So L inverse of f of s into g of s as per the above Laplace transform in convolution theorem is L inverse of f of s. So L inverse of s by s square plus a square convolution L inverse of g of s, that means 1 by s square plus b square. What is L inverse of s by s square plus a square? Which is 1 by this value as cos at star L inverse of 1 by s square plus b square as 1 by b sin bt. That 1 by b I will write in front of that, which is 1 by b, you know, convolution of two functions definition, f of t convolution g of t, which is integral 0 to t f of u, that means cos au, into g of t minus u, that means sin b into t minus u into du. Just I applied convolution of two functions definition. Now apply cos a sin b formula by trigonometry, 1 by 2 sin of a plus b minus sin of a minus b. So by trigonometry, cos a sin b, which is nothing but 1 by 2 sin of a plus b minus sin of a minus b, where a is au, b is bt minus bu. Apply this, that 1 by 2 I will write in front of the integration. Already I have 1 by b in front of that. So hence it is 1 by 2b integral 0 to t sin of a plus b, that means au plus b is bt minus bu minus sin of a minus b, that means au minus this b, bt minus bu multiplied by minus will get minus bt plus bu into du. Now sin of, I will take u term as common, a minus b into u plus bt minus sin of, I will take u as common, a plus b into u minus bt into du. Now already know sin integration. What is sin x integration? It will be minus cos x. So in the way, sin of a minus b into u plus bt with respect to u, its integration is minus cos of bt plus a minus b into u by this, differentiate the above, a minus b into u differentiation 1, so a minus b, this bt differentiation becomes 0. Again differentiate the next, integrate the next term, that sin integration is minus cos, already I have minus, so minus of minus is plus cos a plus b into u minus bt by, differentiate this and write it in denominator, a plus b is constant, u differentiation is 1 and bt differentiation becomes 0 between the limit 0 to t. Apply your upper limit u equal to t, we will get minus cos bt plus at minus bt by a minus b plus cos of at plus bt minus bt by a plus b. This is for your upper limit. Before going to lower limit, put minus sign. Substitute u equal to 0. Then this term becomes 0. I have only minus cos bt by a minus b plus, I will apply u equal to 0. We will get cos of minus bt. What is cos of minus theta? Cos theta. Hence cos of minus bt is cos bt by a plus b, which is minus cos bt minus bt gets cancelled, at by a minus b plus bt minus bt gets cancelled. So cos at by a plus b minus cos bt by a minus b plus cos bt by a plus b. Now take cos at as common, we will get minus 1 by a minus b plus 1 by a plus b. Take an LCM and simplify. Similarly here, take cos bt as common, then minus 1 by a minus b plus 1 by a plus b. Take LCM and simplify, we will get your f of t is cos bt minus cos at by a square minus b square. That is your required L inverse of S by S square plus A square into S square plus B square. Thank you, students.